Hi, this is part 2 of the Pythagorean theorem. I'm going to do just 2 examples, but the 2 examples I'm going to be doing are not just about the Pythagorean theorem, but also about how they can be used in problems that have a lot of different steps. This is going to be a pretty big issue when we actually come to the issue of, well, finding the area of triangles. It's not going to be dry and cut as find out what the area of a triangle is. It's going to be, well, we need to find a base and the height, and it's going to be a lot of other stuff. And then also it can be used for circles, and we'll do an example of a circle in a minute. So the first example we got right here is, well, example number 1 is find the triangle's area. So we're trying to figure out what the area is of this triangle. Just looking at it right now, we know that this leg is 8 feet, and the hypotenuse is 10 feet. So the first thing I would think of is, well, what is area? So I'm actually going to put that under step 2 down here. Well, the area of a triangle is equal to 1/2 times the base times the height. Well, the base and height of a triangle meet at a 90-degree angle. Sadly enough, and base and height could be interchangeable, but they still have to meet at a 90-degree angle, and you need 2 of them. This is only one of them, really. 8 feet's only going to work for one. We have to figure out let's say just to get this one over with, let's say 8 feet is the base. What's the height? Well, it's however long this side is. This is where Pythagorean theorem steps in, and we can use it to find the area of the missing side of the triangle, and then find the area of the triangle. So the step 1 first off is we have to use Pythagorean theorem. I always start, as always, a squared plus b squared equals c squared. And I'm going to zoom in so we can get a little bit of a better view of this, right? Okay. Balance line. Okay. Well, 8 is a leg, so that means it could be A or B. So let's say it's A. Let's say it's A. So we'll have 8 squared plus b squared is equal to, well, c squared is the hypotenuse. C is always the hypotenuse, so that's 10 squared. Okay, well, 8 squared, let me see, 8 times 8 is 64 plus b squared, which is, well, that's 100. Okay, well, the opposite of positive 64 is negative 64, so I'm going to, or I can subtract 64 from both sides, so when I rewrite, let's just go and do that. Plus b squared equals 100 minus 64. So this is going to be 0. 64 minus 64 is 0. B squared would be equal to, well, that's 36. I'm going to rewrite. Well, the inverse operation of square is square root. So b equals 6 feet. And the units do matter. Well, there we go, it's 6 feet. So let's go back up here. I'm going to add that to my lovely picture. And I'm going to say, well, that's 6 feet. Now, and we don't need the 10 anymore. 6 feet is, let's call that the height, and 8 is the base. Now I have what I can plug into for the area. So now I'm going on to step 2. I'm actually able to plug in the values for the area. This is going to be half of the base. Well, the base is, we said 8, and the height is 6. Now I'm just going to multiply straight across. 1/2 times 8 is 4 times 6, and 4 times 6 is 24. An area is always in something squared, so it's in square feet. So the area is 24 square feet. And then we're done. That's the answer. So when it says find the triangle's area is 24 square feet. So the Pythagorean theorem was really useful if I was trying to figure out the area of the triangle and all I knew was a leg and a hypotenuse. I used the theorem to figure out what the other leg was equal to. And that's where the big payoff is for the Pythagorean theorem. I'm going to open up a little program. This is called GeoGebra, and this is a really useful program. I've mentioned it a couple times in class. It lets you do algebra and geometry stuff on a computer program, and I don't know, it's really nice. So right here I've got, well, this side is equal to 8, this side is equal to 10. And I actually got a little program that tells me what the area is. Well, the area is 24. If I adjust what this is, I actually end up changing exactly what's going on. Now it's 18 because I changed what the hypotenuse is, which changed what this was. So that's kind of neat. Zoom out a little bit. Let's play with this a little bit. Let's see. What if I made this 12 feet? 12 feet, 12 feet, 12 feet. Okay, so now we're at 12 feet. And let's make this, let's try and go 13. Oh, there's 13. Hey, look, that's a 5, 12, 13. I know this side's equal to 5. Half of 12 is 6, and 6 times 5 is, hey, 30. So this is really cool because I can adjust things instantaneously, and this program is telling me what the area is of the triangle. So that's kind of neat. And this is a free program that you can download at home and play with. So I think that's really cool. Heck, let's go on and do one more problem from this little dealio. Let's say you have a circle with a right triangle inside of it. This is called an inscribed right triangle. This might be even an easier question, I think, if you know your vocabulary. It's asking how long, it's asking what is the circle's radius. So let's just real quick mark the radius. The radius is from the middle of the circle to here. So they're asking how long this is. Let's call this D. So they're asking how long is the radius. So let's call it R for radius. Why not? Because D is the diameter. This is actually something you'll learn in geometry, but a right triangle, these two things are called chords, and we're going to get into that a bit more. But something you don't quite learn, say, the high school geometry is, well, this, there's like a piece of paper thing right there. If this is the diameter, two chords always make a right triangle. So if I moved this around on here, it would stay a right triangle, which I think is kind of neat. So, well, definitely neat. So that's kind of cool, I think. So let's see. I need to find out radius. Well, if I rotate this around, that's a right triangle, and oh, that's right, Mr. V just said that this must be the diameter. The diameter is equal to, and so let's go to our part 2. I know the diameter is equal to 2 times the radius. So all I have to find is the diameter, and then I can solve for the radius. Great idea. Again, this is a right triangle, so let's use Pythagorean theorem. A squared plus b squared equals c squared. I'm not going to zoom in because you probably can figure out, this is a 5, 12. I'm sure you can figure out what the other side is, but from the common triangles that I've been using so often. See, 5 squared plus b squared is equal, or sorry, 12 is a leg. So I'm going to keep that over here actually. We're looking for the hypotenuse. See, that is 25 plus 144. C squared is then equal to 169. And hey, the square root of 169, let me think, the square root of 169 is definitely 13. And I'm using the units in centimeters, so let's say it's 13 centimeters. So that's this whole side. Well, that's the diameter. Oh, I can plug that in right there. Okay, 13 is equal to 2 times some number. So now it's a one-step equation. Let's see. The opposite of multiplying is dividing. So I'm going to divide both sides, because whatever I do on one side, I got to do on the other, by 2. This is then equal to 1, and the radius is equal to 6.5 centimeters. Supposedly. So we're saying this radius is equal to 6.5 centimeters. I don't know, maybe, that's not it. Dang it, wrong one. Oh, look, there it is. Okay, so let's go to here. I'm looking for the distance from here, the radius, so from here to B, 0 is the center. This thing is 5, that thing is 12. Okay, well, we can take that and we can actually figure out how long it is. I can use this right here and I can say what's the distance, okay, from O to B. Hey, look, there it is right there. Right here, it is 6.5. Heck, I can even blow it up a little bit. Let me make that text a little bit bigger. Look, from O to B, it's 6.5 centimeters. Ta-da! This program is really neat. I just used it to show you how to find the distance of a line segment. It's really cool. Also, you can use it to draw pictures using shapes, and it tells you areas and lets you make circles. It's actually a pretty neat, I think it's a really neat program, and best of all, it is free on the internet. It is literally GeoGebra, free. So that's part 2 on Pythagorean theorem, and this program we're going to be using a bit more once we get into the unit 7, 8, 9, and 10. So have a great day. See you next time.